Welcome to MEDVERSE, and today we are going to quickly revise the chapter Biostatistics. Biostatistics is basically a chapter which is dealing with the variations, comparing the variations to find if the variations are significant or non-significant, or to define what is the cutoff value. For in practical appliances, like for calculating a sample size, for presentation of data, for processing of data, for defining a event, the burden of disease, how many people are in studies, epidemiological studies, it is important, to cut off determination basically. So data may be of two types. One is a quantitative data and qualitative data. One is writing quanti and I am writing qualitative and quantitative data is a measurable data. Qualitative data is a countable data. Quantitative data is how much. Qualitative data is how many. So what is quantitative data? Height, weight, TSH levels, HB1AC levels, like this. Pulse rate is also measurable data, right? Number of RBC, like this. Platelet. And qualitative data is basically how much, like gender, how many, male or female, blood group. Can you calculate how many blood groups are there? No. You will calculate the type A, B and O. RH or RH positive or RH negative, like this. Rich or poor. Okay. This type of data is comparative data, is called as dichotomous data. Healthy, sick, rich, poor, all of this. Okay, so we can have this type of data. And now let's talk about the scales of measurement. Scales may be of basically four types. You can remember Neuer. N is nominal, O is ordinal, I is interval, R is ratio. Okay, nominal scale means a qualitative data with no order. So basically this nominal and ordinal are for qualitative data, and interval and ratio is for quantitative data. Nominal, ordinal, no for quali and IR for quanti. Nominal scale means type of disease, then some obese or non-obese, like this type of things. So it have no order. Ordinal data, you can remember name, order is there. Like visual impairment grading. Visual impairment grading is a ordinal data. Interval data means no, it is absolute, has no start point or zero. No zero is present. No zero. Degree Celsius, degree Fahrenheit, decibel, they don't have zeros, right? They don't have a starting point. This ratio scale has a zero start point, absolute start point. Height, weight, age, temperature, all of this. Okay, this type of data are represented in your ratio scale, right? Understood? And agree disagree is represented by Likert scale. Likert scale is representing the agree, disagree, all of this. After this basic introduction, let's move on to the scales. What are the scales? We discussed about scales. Let's talk about some tendencies. Central tendency. Measurement of central tendency. So you know that what central tendencies, mean median mode. Mean median mode. Mean means the average of all values, the simple one. It is the best one. But disadvantage is that it is the most affected by outlier. What is the outlier? Outlier is basically an extreme value. 2, 12, 2, let's say 3, 4, 2, 1, 3, 4, 100, 2, 4, 1, 3. Which is the outlier? 100 is the outlier. This is the outlier. So mean is the most affected by outlier. This is an MCQ. Most affected by outlier is mean. Let's talk about median. Median is when you arrange a data in ascending or descending order and take the middle value. Take the mid value. If a data is even number, let's say 2, 4, 2, 6, 8, 10. So you will arrange it like 2, 2, 4, 6, 8, 10 like this. Okay, which is the middle value? There is no middle value here. So you take this 4 plus 6 by 2, divided by 2 is 5. 5 is the median. 5 is the median. And remember, median is the least affected by extreme values. This mean can be of many types. It can be arithmetic mean. Okay, arithmetic mean basically you add all the thing by sample size, number of observation. You can have geometric mean. Okay, 10 to the power 6, 10 to the power 99, 10 to the power 749, all of this. You can use harmonic mean. Harmonic mean is used for fractional data like 1 by 10, 1 by 100, all of this type of data. Fractional mean. We have a formula, mode equal to 3 median minus 2 mean. 3 median minus 2 mean. Mode equal to 3 median minus 2 mean. This is the formula. Okay, so what is the mode? Mode is basically the most frequent observation. Most frequent observation. Let's say 2, 2, 4, 6, 7, 2, 3, 4, 6. What is the most frequent? 2, 2, 2, 3 times. So mode is 2. Okay, it is the most robust value. It is least to change with variations. Okay, this is done. Okay, let's talk about the measurement of variation. How to measure the variation? So we have something called range. What is a range? Range tells how big is the data. It is the basic measure of variation. Okay, this is the range. So range is basically maximum value to max value minus minimum value. Okay, this is the range. What is the standard deviation? How much is the data deviating from a mean value? This is a mean value. How much is the data deviating from the mean? How much is the data? This is the mean value, maximum value. How much is the data deviating from mean value is basically standard deviation represented by sigma. Okay, and this is also called RMSD. Standard deviation is also called RMSD. Sigma equal to RMSD. RMSD means root of mean square deviation. Okay, so sigma is basically summation of x minus x square by n root over. X is the value, x square is the mean, and you have to submit the value, and n is the sample size, n is the number of values which is there. Okay, here if it is valid if n is more than 30. Sigma is equal to summation x minus x whole square by n minus 1 if n is less than 30. So you have to remember the formula. For example, let's say there is a data 2246. So what will be the sigma? Sigma is equal to x. Let's say for 2 minus x bar is 2 plus 2 plus 4 plus 6, the mean. Okay, 6 plus 4 10, 10 plus 4 14, 14 by 4 is 7 by 2. 2 minus 7 by 2 whole square by n. Number of observation 4 root over. Okay, but n is less than 30, so you have to minus 1. Okay, so basically this is the thing. So you have to calculate the standard deviation. This is the standard deviation. Okay, variance. Another thing is variance. Variance is basically square of standard deviation square. So it is basically summation of x minus x whole square by n minus 1 if n is less than 30. Okay, you just remove the root over. So variance is basically square of SD, that is this one. Okay, we have something called coefficient of variation, COV is basically SD by mean into 100. Okay, this is the COV, that is coefficient of variation. Coefficient of variation is HD by B into 100. Now let's talk about the normal distribution. Normal distribution, which is also called as Gaussian distribution. Gaussian distribution. Okay, this is the normal distribution. This is the normal distribution. Okay, this is the Gaussian distribution, normal distribution of a data. Basically, it's bilaterally symmetrical. Bilaterally symmetrical distribution. It's a bell-shaped curve. It is a bell-shaped curve. Okay, here in the middle of the distribution, mean equal to median equal to mode. Mean equal to median equal to mode. For a normal distribution, mean equal to median equal to mode always. Okay, and this area under curve is 100%. Area under curve, or it is called 1. Area under curve is called 1. Okay, so AUC is 1, standard deviation is also 1, variance is also 1. Standard deviation and variance is also 1. Variance is basically SD square, right? So if SD is 1, then variance is also 1. Okay, and okay, so we have to discuss some of the things which you have to understand in the standard distribution. Let's draw it again. So this is the standard distribution. This is the thing. This is the middle value. Middle is the null value. We call it null value. Null value here at this point, mean equal to median equal to mode. Mean equal to median equal to mode. Okay, so here let's say we go one standard deviation far. 1 standard deviation plus 1 ST. We go 2 standard deviation first plus 2 ST. We go 3 standard deviation first plus 3 ST. Can go more. Here we come back minus 1 ST. Here we come back minus 2 ST. Here we come back minus 3 SD. Okay, so remember 68.2% of population lies between plus 1 and minus 1. 68.2. Okay, so whenever someone tells you that a data is the mean value is 20 and standard deviation is 5, plus 1 ST means this will be 25. This will be 25, right? And minus 1 means this will be what? 15. 20 minus 5 is 15. So what percentage of population will lie between 15 and 25? 68.2% of population will lie between 15 and 25. What percent of population lies between 20 and 25? 34%. Are you able to understand? What percent of population lies between 15 and 20? 34%. Are you able to understand? Yes. Okay, so we understood that 68.2% of population lies between minus 1 ST and plus 1 ST. This between minus 2 SD and plus 2 SD, 95.4% of population lie. 95.4%. And between minus 3 ST and plus 3 ST, 99% of population lie. 99.7. So you can remember plus 1, 68, 95, 99. 68, 95, 99. Okay, done. So this zone is basically minus 2 to plus 2 is called as normal zone. So what percent of population lies in the normal zone? 95.4%. Are you able to understand? Yes. For what it is used? It is used in cases of epidemic. In epidemic, we tell that if the cases exceed plus minus 2 standard deviation, if the cases exceed plus 2 standard deviation, that is, if the cases were occurring up to this, but now they have exceeded this, okay, this is an epidemic. It is used in growth chart. We tell that minus 2 SD is basically malnourished. It is used in many things, right? Many things. Okay. Then we'll define a thing which is called Z. What is Z? Z is basically standard deviate. So standard deviate is basically location of a value. In terms of standard deviation. So location of a value in terms of standard deviation is called standard deviate. Okay. Z equal to observed value minus mean by standard deviation. So Z equal to x minus x dash by ST. Okay, and this mean is called as expected value. Expected value. Okay, understood? Okay. Now we will go to another distribution which is called as Poisson's distribution. This was the Gaussian distribution. Okay, you understood Z? What is Z? Z score, we call it Z score. We also call it standard deviate. Standard deviate. So if you are asked to calculate the Z score, you can use this formula x minus x test by standard deviation. Okay. And standard deviation, let me revise the formulas. Standard deviation is basically summation of x minus x test whole square by n. Okay, and we define variance. Variance is standard deviation square. Coefficient of variance is ST by mean into 100. And we talked about normal distribution or Gaussian distribution. We talk about the normal zone 68.2, 95.4, 68, 95, 99. You just remember like this. Okay, this is a normal distribution. Now let's move on to another thing, which is the this is small topic. This is Poisson distribution. You have to understand what is Poisson's distribution. Poisson distribution. This is basically probability of a event to occur in a time. Probability of a event to occur within a time frame. Probability of a event to occur within a time frame is basically Poisson distribution. Okay, and only one variable is known. Only one variable is known. Like number of head trauma cases in OPD on a given day. Number of students giving let's say NEET. Number of people visiting OPD on Monday. Okay, like this is distributed, is represented in Poisson distribution. Okay, this completes our Poisson distribution. Next we'll move to some of the inferential statistics and p values. दस भी नहीं बजे मोर हेल्प करले मा कहउछन बा मैं पढौछन जे एटा तो मना करथि तते अरे यार मोर एग्जाम अच्छे ना तले पढौछन एग्जाम नेतले कहीं पढ़ाती तो एग्जाम से तो कहीं पढौछ निजे पढ़ले बोरिंग लगवा ना हां मा तो जानछ डॉक्टर करवा काना करबार छै कलरिंग और काटबार छै कलरिंग और काटबार छै करथा जेते हबा काली दरकार केतेटा अछि बहुते बहुते अछि काली दरकार आगरो कर देति तो केने करू तो थिली केते बोले दुई दिन करछ वाह तो करू मैं आसमी डिसाइड दे करे केते टाइम लगो क्या आने कितना टाइम लगा सर देख रहे आसमी कितना अच्छा देख ले और तोर काम तो करवार कथा So we are into the inferential stats. Inferential statistics is basically a large group of data. So mu, we define mu. Mu is basically the population mean. Population mean, the mean of means. Mean of all means. Mean of all means. We define something standard error. Standard error. Standard error is basically deviation of all deviations. Deviation of all deviations. Total standard deviation. So standard error, we have standard error of mean and standard error of proportion. Standard error of mean is basically standard deviation 1 by n1 plus standard deviation 2 by under root n2, like this. Standard deviation of proportion is basically prevalence by 1 minus prevalence, or you can say 100 minus prevalence by n plus P 1 minus P by N. Okay, like this. This is P1, P1, N1, P2, P2, N2. So basically this 1 minus P is called Q. Okay, so P is basically prevalence and 1 minus P is called as Q, and Q is basically a measure 1 minus P. Okay, 1 prevalence into 1 minus prevalence by N. N is the sample size. Okay, so standard error of proportion and standard error of mean, these are the formulae. Okay, now let's talk about p value. P value is basically a probability value, a chance. Okay, so probability p value at center of a normal distribution will be 1 because the chance is 100%. Mean equal to median equal to mode means 100% chance. Okay, so p value is used for comparing the effectiveness. Okay, so basically whenever you go out, here the p value is 1, but whenever you go like out, this p value decreases. Probability of chance happening the event decreases, right? So p value is basically the chance. Okay, if the p value is more than 0.05, we call it as non-significant p value. If the p value is 0.05 less than 0.05, it is called significant p value. Okay, significant p value. So whenever you tell that a p value is less than 0.05, so what do you mean? You mean that there is a hypothesis 1, which was the original thing. Hypothesis 1, which was called as the null hypothesis, H0. This is the original statement you are believing. And we have a hypothesis 2, which is the alternate hypothesis. Whenever you do a research, you take a null hypothesis, which is the original one, you take an alternate one, HA. When we say that a drug has p value less than 0.05, means it is significant. That is, it is abnormal. Basically what happens is that we tell that this p value, I told you that minus 2SD and plus 2SD. This was called the normal zone. Here p value is 1. At plus 2SD p value is 0.05. At minus 2SD p value is 0.05. If it is less, p value less than 0.05, p value less than 0.05, we call it abnormal. This is normal and here it is called abnormal. So this is abnormal. So abnormal means the null hypothesis is rejected. P value is less than 0.05, null hypothesis is rejected, and alternate hypothesis is accepted. Okay, alternate hypothesis is accepted. Understood? Null hypothesis is rejected, alternate hypothesis is accepted. Okay, understood? Okay, there is another concept which is called null hypothesis, and this all we discussed. Let's discuss something about errors. Let's say your p value comes more than 0.05. It is significant or non-significant? It is non-significant. So you accept the null hypothesis or reject it? Accept null hypothesis. Means it was null hypothesis is true. It is true. If you accept the true hypothesis, you are correct. There is no error. But due to something, you are telling it is actually correct, but you are rejecting it. If you are rejecting the correct null hypothesis, we call it type 1 error. Okay, or you can say false positive error, or you can call it alpha error. It is the possibility of finding an effect by chance which doesn't exist in reality. It is not existing in reality, but you are finding it, you are calling it false. Okay, you are rejecting the true hypothesis. Okay, another situation, p value less than 0.05, it is significant. So is the null hypothesis accepted or not? Not accepted. So if you are rejecting the false hypothesis, if you are rejecting it, no error, you are correct, no error. But if you are accepting the false one, you call it type 2 error. Type 2 error. Okay, so you understood what is type 1 error and type 2 error. This is called as beta errors. Okay, understood? Okay, after this we'll go to some other things which you call it a test of significance, tests of significance. Test of significance is basically maybe two types. You can have parametric test, you can have non-parametric test. Parametric test is for quantitative data, quanti data. Non-parametric for quali data. If you have two groups, first let's discuss single group. If you have single group, you will use paired t-test. And here for quali data, you will use McNemar test. Two groups, you will use unpaired t-test. And here you will use chi-square test. This is the maximum used test, chi-square. And you have more than 3 groups. Here you use ANOVA, analysis of variation, ANOVA. And here you use Kruskal-Wallis. This is KRUS, Kruskal-Wallis test. Okay, let's take an example. You checked 3 villages for, let's say, worm infestation. So is it qualitative or quantitative? Of course, it's qualitative. How many groups? 3 groups. Which test you will use? Of course, Kruskal-Wallis. You checked BP levels in phase 3 students in boys and girls. BP level, quali or quanti? Quantitative data. How many groups? 2 groups. Quantitative data, 2 groups. Which test? Unpaired t-test. Unpaired T. Prevalence of smoking in 2 groups. Quali or quanti? Qualitative data. How many groups? 2 groups. Quali and 2. Chi-square test. Okay, understood? Okay. Now we have some other tests. We have some tests like Dickson Q test. Dickson Q test is used for outliers for extreme values, outliers. Okay. We have another test which is called Wilcoxon rank test. Wilcoxon rank test is basically used for ordinal data. Okay. And we have something called Kolmogorov-Smirnov. This is Russian scientists for normalcy of data. If the data is within the normal range or not, you have to check. Here, Kolmogorov-Smirnov. Dickson Q for outlier. Wilcoxon rank for ordinal. Then we'll discuss about kappa statistics. which is a INICET topic. Kappa statistics basically is the agreement check. If one perfect agreement, basically what happens is that we gave 100 chest x-rays, just understand, 100 chest x-rays to a medicine resident, MD medicine, and to, let's say, MD pulmonology. MD medicine says that 50 chest x-rays are TB. MD pulmonology states that 65 are TB. So what do you think? There is agreement in some x-rays, there is agreement in some, there is disagreement between these two. Measurement of this agreement is done by Kappa statistics. This is an advanced concept. Okay. So here there is a formula. Kappa is equal to observed agreement minus expected agreement by total agreement minus expected agreement. Observed minus expected by total minus expected. Okay. Then we have a condition for cancer patient. For cancer patient, the cancer patient may survive based on prognosis factors. So it is a step ladder pattern thing, and this step ladder is called Kaplan-Meier analysis. Okay. Kaplan-Meier analysis. Okay. And we have something called Z test. Z test is done for large sample, like n more than 30. Z test, you have to know Z test. Okay. Now we'll discuss regression analysis. Okay. Regression analysis. So for regression analysis, you have to understand that it follows y equal to mx plus c. Okay, plus minus error. Error may be there, may not be there. We just focus on this. This is the equation of straight line. M is the slope. You know all this. Okay, M is the slope. X is the variable. And c here is the coefficient of regression. Which is also called as Spearman regression coefficient. Spearman regression coefficient. This is coefficient of regression. Okay. Then let's move on to the skew. So what is a skew? Skew means deviated. This is a normal distribution, bell-shaped curve. If the distribution is tailing at right end tailing, this is called as a right or positive skew. Here, mean, median, mode all look towards right side. Okay, so mean is greater than median is greater than mode. This is a right skew. If the tailing is at this left side, it is called as left skewed or negative skew. Here you write mean, median, mode. All of this will look at left side. So which is the largest measure here? Mode. Which is the maximum measure in right skewed? Your mean. Okay. Done. Okay. Now we have something called quartiles. Problems are there, so make sure to solve questions. Quartiles. So here we have a line like this: Q1, Q2, Q3. This total is 100%. And this is individually 25%, this is 25%, this is 25%, this is 25%. Okay. This is the first quartile, second quartile, third quartile, and fourth quartile. This is a type of representation of data. Okay. Then we have a box and whisker plot. Here the box is there and whiskers are there. This is 25%, this is 25%. Box is 50%. Okay. This will be a normal distribution. Look at this. This is a normal distribution. If it is like this, if the box square plot is like this is a positive skew or right skew If it is more towards left side. If it is more, the box is more towards which side? Right side, then it will be negative skew or left skew. Understood? This is the thing. Here we define a thing which is in the quartiles. I forgot to tell you, this is interquartile range. IQR is basically Q3 minus Q1. Interquartile range. Here the box is representing the IQR. Box is representing the IQR. Okay. Now we'll have a discussion on the sampling methods. So you can do either non-probability sampling, non-probability, or you can do probability sampling. This can be convenient, purposive, quota, and snowball. Convenient, which is the easiest sampling. Purposive, you are doing sampling for another purpose. Purposive sampling. Quota sampling, you will predefine the rules and will do sampling. Quota sampling. Snowball sampling, for diseases which have hidden cases like drug abuse, due to embarrassment, HIV also, so let's say acid attack, all of this hidden cases, for you do snowball sampling. We have to discuss probability samplings, which are better. These are better. We can have simple random, we can have systematic, stratified, and cluster. Simple random, systematic, stratified, and cluster. The simple random sampling means it's the easiest and best method of choosing random numbers. Okay, let's say you took 20 people, you are calling numbers like 1, 15, 6, 8, all of you come here. So simple random sampling. Systematic means you are selecting every nth term. Means you are selecting 20 patients, you are calling 5, 10, 15, 20, nth term. Okay, every fifth individual. Stratified sampling means you have to divide the population into two strata. This is first strata, this is second strata. Okay, and you will do sample. So divide the population based on this and do sample. Okay. Cluster sampling, for health programs it is done. For health programs, like for universal immunization program, UIP, we made 30 clusters of villages, 30 clusters, and from each cluster you select 10 children per cluster. So 200 children. So select and assess the full immunization status. Full immunized means 1 year. Till 1 year, what percent of children had taken the vaccine. Okay. So in National Iodine Deficiency Control Program, NIDDCP, we used 30 into 90. 2,700 children. Means 30 clusters and 90 children each from cluster. So basically in cluster sampling, you are not stratifying the population. Basically what you are doing is you are selecting random clusters, and you don't make clusters. They are naturally occurring clusters, These villages, you haven't made villages, you have made clusters out of the villages, right? Easy. Okay. Now for this we'll have the thing which is validity. Let's discuss about degree of freedom. So degree of freedom, if any question is given, then you have to do row minus 1 into column minus 1. This is row, this is column. row minus 1, column minus 1. Let's say for 4 into 4 table, what will be the degree of freedom? 3 into 3, that is 9. Okay, done. Okay, now we'll talk about graphs. Representation of data. Now we are into representation of data. So either we can have qualitative data, it's a quanti, and here quali. For quantitative data, you will use histogram. What is a histogram? Histogram is for joined columns or charts like this. Joined columns or charts. This is a histogram. This is a histogram. Age pyramid is a histogram. Age pyramid is a histogram. Okay, all of this. Histogram. Second, you can use frequency polygon. Frequency polygon or curve. Third, you can use ogive. Ogive is basically cumulative frequency polygon. When you are representing cumulative frequency polygon, use the ogive. Okay, so it is representing cumulative frequency. Cumulative. It is the sum of frequency of the same class interval as well as the preceding class interval. Okay, for example, 20, 40, 60, 80. So cumulative 20. Here cumulative 60. Again cumulative 120. Again cumulative 200. So a ogive will be made. This is the ogive. Okay, ogive chart. So ogive chart. Okay, this is also a method of representing quantitative data. Then you are using scatter plot and line chart So histogram, frequency polygon, ogive, scatter plot, line chart. Okay, these are the methods of representation. So what is a scatter plot? Scatter plot is used for correlation. Let's talk more about correlation. Correlation means the strength of relation between two variables. Let's say relation between weight of an individual by height of an individual. This is a scatter plot. The scatter plot, commonly done in dotted format like this. Okay, scatter plot. You can have linear or non-linear, which you must have remembering the coefficient, that is Pearson-Spearman coefficient. Okay, Pearson-Spearman coefficient. You can have if the plot is like this, that is Pearson coefficient is +1. You remember y equal to mx plus c. This c is basically r. R is the coefficient, Pearson-Spearman coefficient. R is +1. It is a positive correlation. If it is like this, negative correlation. If it is like this, only scatter, R is 0, no correlation. No correlation. Okay. If it is like this, no correlation. If it is like this, no correlation. Okay, we can have curvilinear correlation also, which is a advanced concept. This is the curvilinear correlation. Curvilinear correlation. Okay, and here we have something called coefficient of determination. Coefficient of determination, which is basically R square. R square. R is basically Pearson-Spearman correlation coefficient. Okay. Whenever you say that when R can range only up to -1 to +1. R equal to 1.2. Is it correct? No. R equal to 0.6. Is it correct? Yes. When R is more than 0.6, we call it a strong correlation. Strong correlation. When R is less than 0.4, we call it as weak correlation. Weak positive correlation. Okay, so that was about the scatter plot. Now we'll see time chart. Time chart is basically nothing but frequency with time. So you have to, if you have to see the trend of diseases, trend of various diseases. If you have to see the trend of various diseases, then you can use the line chart. If you have to see stem of various diseases, you can use the line chart. Okay. Now we'll discuss about qualitative data. Qualitative data can be represented. This is quantitative: histogram, frequency, ogive, scatter plot, line chart. Qualitative data we can use bar chart, spot map, chloropeth, vein, stem and leaf, all of this, and pie chart also. Bar chart, spot map, chloropeth, vein, stem and leaf, pie chart. Okay, bar, spot map, chloropeth, vein, stem and leaf, and pie chart. Okay, and forest plot also. Forest plot basically is used in meta-analysis. That is not much important. Vein, let's discuss about vein. Vein, you know, vein diagram, overlapping qualitative data is represented in vein diagram. One is stem and leaf plot. Stem and leaf plot. Basically what you are doing is 46, let's say, not 46, 461 and 12, 18. You have to represent the data. How will you represent? You will represent like this: 461, 1, 2, 1, 8. You make a line here, leaving only one. This is the stem, this is the leaf. Okay, so how will you represent? 1, 4. Then you do 1 is not there, so blank. 2 is there. Okay, 4 means 1 is not there, 2 is not there, 3, 4, 5, 6 is there, right? And 18, 1, this is not there, 8 is there. So this is the stem and leaf plot. This is the leaf, this is the leaf, and this is the stem. Leaf, this is the stem. Okay, this is the stem and leaf plot. Then use pie chart. Pie chart for qualitative data. You know all about the pie chart. This is the pie chart, right? It is used for illiterate people. So some ask illiterate people, you can use it. You can use any technical data. You can use it for some comparative data. Okay. Then we have chloropeth. Chloropeth is basically intensity of variable. Like if you have seen the India map like this, the India map in which it was shaded. Okay, this brown, less brown, very less brown, more dark brown. Okay, like this. So when you are representing any burden of disease in a map, this is called chloropeth. Like amount of rainfall on 30th June all over India, represented by chloropeth map. Okay, spot map was used for this cholera. You remember John Snow, natural experiment of cholera? He used a spot map of London. Okay, so it is basically a map of the city in which specific points are marked of a case of a disease or of a disaster which is occurring. So it is basically used for disaster management. Pictograph for mass awareness. Okay, pictograph for illiterate population. This is also for illiterate. Forest plot. This is a topic of epidemiology. Forest plot is used for publication bias. Okay, this is also important. Forest plot for publication bias. Some other things like bubble graph is there. This is also like if you have seen the COVID cases, then bubbles are there in the world map. Okay, bubbles were represented like this on world map. This is bubble graph. Intensity of a disease, same for disease intensity. Tree map in proportions. Qualitative data in proportion. And we have another thing, the last thing, that is called fishbone diagram. Fishbone or Ishikawa diagram. Ishikawa diagram is basically root cause effect model. Okay, root cause effect model. Let's say this is the disease, and what factors are contributing. Let's say genetics, let's say environment, let's say immunological. Let's say lifestyle is not contributing. Lifestyle is not contributing. So we'll cross it like this. So this is basically a Ishikawa diagram or fishbone diagram for root cause effect model. Okay, like this a fishbone type of structure. So that completes our biostatistics in 50 minutes, and all the concepts and all the advanced points also. After this you have to do only the questions for INICET and for your NEET-PG, and for your boards you don't have to do anything, just revise the formulas and revise the theory again and again for writing purpose, and nothing else is required. That's all, and let's meet in another video. Bye bye.